Hi everybody, in this video I'm going to go over practice problems 2, 3, and 4, okay, from impulse and momentum. These are the problems we didn't get a chance to go over together in class, so I just wanted to make a video going over this. So this is, again, impulse, momentum, extra practice, 2 through 4, okay? All right. Let's get started. So we're going to start with number 2. And problem number 2 says, in a ballistic test at a police department, Officer John fires a 0.006 kilogram bullet at 350 meters per second into a container that stops it in 0.0018 seconds. What is the average force that stops the bullet? So in all of these problems, we're going to start with a sketch for before and after our collision. So before, we have our bullet and it is moving, and after, the bullet is stopped by the container, okay? And now we're gonna label it. So our mass of the bullet we know is 0.006 kilograms, and the velocity is 350 meters per second. Then after the collision, the mass does not change, so it's still 0.006. And now our velocity, since the container stops it, our velocity must be 0. We don't know the force, but we do know the time is going to be 0.0018 seconds. I also want to point out that our system is the bullet. Okay? So now we have a sketch, and our next step is we're going to make a impulse momentum bar chart. So let me draw my chart, and we have before, J for impulse, which is our change in momentum, and then after. And before, we know we're going to have some positive momentum because we have a positive velocity. And then after, we know that we have no momentum because we have 0 velocity. So that means our impulse is going to be negative. And now we can make up this equation: initial momentum plus impulse equals final momentum. And then if you remember, momentum is mass times velocity. So I'm going to replace this with mass times velocity 1 plus impulse is force times time equals momentum is mass times velocity 2. And now we can just go ahead and start plugging in our numbers, okay? So we know our mass and our starting velocity, so I'm going to do 0.06 times 350 plus, I don't know my force, but I do know my time, so I'm going to do F times 0.0018 equals, our mass is 0.006, and our velocity is 0. And now we can just start solving this out. So if I put this in a calculator, 0.006 times 350 gives me 2.1 plus 0.0018F equals 0.006 times 0 is 0. Now I'm going to subtract 2.1 from both sides, and I get 0.0018F equals negative 2.1, and then I'm going to divide by 0.0018, 0.0018, and if I put this in my calculator, I get negative 1,166 newtons. That's my final answer. And I want you to notice here that this is negative, and that makes sense because we knew our impulse needed to be negative. Also, if we said that our velocity was positive, which we did, that means this is the positive direction. And so the force that the box is exerting had to be negative. So it makes sense to have a negative value. You can always check yourself with that. If the impulse is negative, the force needs to be negative as well. So that's problem number 2. Let's take a look at problem number 3. Okay. So problem 3 says, according to a report on traumatic brain injury, the force that a professional boxer's fist exerts on his opponent's head is equivalent with being hit with a 13-pound or 5.9 kilogram bowling ball traveling at 20 meters per second. 20 miles per hour, which is 8.9 meters per second, if the ball stops in 0.018 seconds. Determine the average force that the ball and the fist exerts on the head. So this is sort of like two problems together. So we're just going to take a look at the bowling ball part because they told us that they're the same. So this is problem 3. And we have our before and our after. So before we have a bowling ball and it is traveling, and then after it stops. Okay. And our mass of our bowling ball is 5.9 kilograms. Our starting velocity is 8.9 meters per second. And then after the collision, the bowling ball still has a mass of 5.9 kilograms, and now since it stopped, its velocity is 0. We don't know the force, but we do know the time is going to be 0.018 seconds. Okay. And again, our system in this case is the bowling ball. Okay, so again, I've made my sketch and I've labeled it with all the numbers that I know. Also notice here that I used the metric units, not the English units. So kilograms and meters per second, not pounds and miles per hour. All right, now we're gonna make a bar chart. So we have before, we have our impulse, and we have after. And again, before it's gonna be positive, and after it's going to be 0, so that means our impulse is going to be negative. Now, I know, thinking forward, that I should end up with a negative force, okay? So let's try this out. We have our starting momentum plus our impulse equals our final momentum. And also, I want to point out here that even though I know impulse is going to be negative, I still put plus because the negative is going to come from the force. So always still put that plus sign there. And then again, momentum is always mass times velocity. So I'm going to say mv1 plus impulse is force times time equals mv2. And now we can start plugging in our numbers. Our mass is 5.9. Our velocity is 8.9 plus, I don't know my force, but I know my time. So I'm putting F times 0.018. Equals, this is our mass, 5.9, and our velocity is 0. And now we're just going to try and solve for F. So let's put this in a calculator. I do 5.9 times 8.9, and I get 52.51 plus 0.018F. And 5.9 times 0 is 0. And I'm solving this the same way. Subtract 52.51 by both sides. I get 0.018F equals negative 52.51. Divide both sides by 0.018. And if I put that in a calculator, negative 52.51 divided by 0.018 gives me negative 2,917 newtons. That's my final answer. So again, same process. I start with a sketch for before and after. And again, when you're doing the quiz, you can do this before and after on a piece of paper. You don't have to put it on the quiz, but I do encourage you to do it because it does help, right? It helps to write out what you know. And you're always welcome to do this on paper instead of typing it up and then either type it up after or just take a picture of the paper. So we have our before and after, and we wrote down all of the information we're given. Then we made our bar chart. From that, we could come up with this equation, starting momentum plus impulse gives you final momentum. We plugged in mass times velocity for momentum, force times time for impulse, plugged in all of our numbers, and then solved. So let's take a look at our last one here, problem number 4. Okay, and problem 4 says a basketball player drops a 0.6 kilogram basketball vertically. So it is traveling at 6.5 meters per second when it reaches the floor. The ball rebounds upward at a speed of 4.2 meters per second. Determine the average force that the floor exerts on the ball if the collision lasts 0.13 seconds. So, again, same start. We do our before and our after. Okay, in our before, we have our basketball and it's moving down. Let's say up is positive and down is negative. And then after it has bounced off the ground, it's now moving up. Okay? And our system is our basketball. Okay? All right, now we're going to put our numbers we're given. So I know from the beginning our mass of the basketball is 0.6 kilograms. And our velocity, it says, is 6.5 meters per second. Now, I know it's moving down, and we said down was negative, so that should be a negative 6.5 meters per second. Then after our collision, our mass is still that same 0.60 kilograms. And our velocity, it says, is 4.2 meters per second, and it's moving up, so that's going to be a positive 4.2 meters per second. We don't know the force, but we know the time is 0.13 seconds. Okay? All right, so we have our sketch. We've written down everything we know. We know what our system is, and now we're going to make a bar chart. So as always, we have before, impulse, and after. And we know before we're going to have some negative momentum because I have a negative velocity. And after we have some positive momentum because we have a positive velocity. So that means our impulse should be a larger positive number. Okay? So we can use this to write the equation starting momentum plus impulse equals final momentum. And again, momentum is mass times velocity, so I can say this is mass times velocity 1 plus impulse is force times time equals mass times velocity 2 for momentum final. Now I can start plugging in my numbers. My mass is 0.6. My starting velocity is negative 6.5. So I'm going to do 0.6 times negative 6.5 plus, I don't know my force, but I know my time, 0.13, sorry. And my final mass is 0.6. My final velocity is 4.2. Okay, and now we're going to try and solve for force. So again, putting this in my calculator, I'm going to do 0.6 times negative 6.5, and I get negative 3.9 plus 0.13f. And if I put in my calculator 0.6 times 4.2, I get 2.52. So now I'm going to add 3.9 to both sides. And I get 0.13f equals 6.42. Now I'm going to divide both sides by 0.13. And when I put that in a calculator, I get a force of 49.4 newtons. And that is my final answer. Okay, so in all of these, we have the same process. We sketch before and after our collision, and we write down our masses and velocities before and after. Remembering to make sure that we have our correct positives and our negatives. Remembering that if it is at rest or if it stops, that velocity is going to be 0. Then we make sure we know what our system is, which is the object that is colliding. And then from that, we make our bar chart. And from the bar chart, we always have the same equation. Initial momentum plus impulse gives you final momentum, or mass times velocity 1 plus force time equals mass times velocity 2. Then you can plug in your numbers and solve for your missing variable. Okay, so hopefully that was helpful. This is going over problems 2, 3, and 4 of the extra practice for impulse momentum. Let me know if you have any questions, and have a great day.